In this video, we'll try to learn a complete example of graphing a polynomial function. So what I'm going to do, I'm going to on the left hand side write down the steps, and simultaneously I'm going to sketch a function which is function of x equals negative x cube negative 4x square positive 4x plus 16. So this is the function I'm going to sketch. So let us see one by one each steps. So the number one step is we need to determine the end behavior. Okay, so determine the end behavior of the function. Okay, so end behavior. All right, now let us see for our particular given function. My particular given function, this is the negative x cube is my leading term. Okay, so my leading term equal to negative x cube. So I can say an, so the leading coefficient is -1 and my n equal to 3. So that's the degree of polynomial. So this is a third degree polynomial. Now something I'm going to write it down, which is the maximum number of real zero. If n equal to 3, then what is the maximum number of real zeros I can get? So maximum zeros or maximum x intercept will be n, which is 3. What is going to be the maximum number of turning points if n equal to 3? So maximum number of turning point if n equal to 3 will be n minus 1. Maximum number of turning point will be n minus 1, so which is 3 minus 1, which will be equal to 2. So in a nutshell, for a third degree polynomial with n equal to 3, I'm going to get a maximum number of real 0 3, and I can have maximum turning point, maximum number of turning point 2. All right, so now let us see n behavior. So with an less than 1 and also less than 0 and also n equal to 3, so let us see how I can find the end behavior. So now this is the lecture we learned before, where I can see that the end behavior is depending on the leading term and an and xn. So if an is less than 0, so an is less than 0, and if n is odd, for my case n equal to 3, so n equal to 3 and a is less than 0, so the end behavior will be what? End behavior will be the one which is showing here. In the left hand side is going to go up, and on the right hand side it is going to go down. So let me try to plot it in this graph. Okay, so I'm going to set up a graph. So I am going to set up a graph paper. So this is my x-axis, this is my y-axis. All right, so n behavior will be what? On the left hand side it is going up, okay, and on the right hand side it is going down. So right hand side it is going down. All right, so that is the end behavior. So that will be end of our step number 1. So let us see the step number 2. So step number 2 is find the real zeros. So find the real zeros, find the zeros of the function, and we know that zeros of the function is finding what? X-intercept actually. So X-intercept, so find the X-intercept, and we know how to find X-intercept of a function. We need to put y, which is equal to function of x, to 0. So okay, we are going to put y equal to 0 in this equation. All right, so let us do step number 2. So step number 2, I'm going to try to do it here. So we get what? We get y equal to, my function of x is what? Negative x cube, negative 4x square, positive 4x plus 16. Okay, so I just simply rewrote my function. So now I am going to put what? Y equal to 0. So I'm going to put this equal to 0. Okay, which is equal to that. Now to solve this problem, first I'll try to factor first two term and last two term. If it works, fine. If it do not work, I'm going to group together the first term with the third term and second term with the fourth term. Okay, so let's try with our first two terms. Okay, so from the first two term, I can take negative x square as a common. Okay, so I can take negative x square common. If I take negative x square out from negative x cube, I am left with x. Now if I take an negative x square from negative 4x square, I am left with what? Positive 4. And then let's see with the last two term, 4x and plus 16. So I can take actually positive 4 out. So if I take positive 4 out from positive 4x, I am left with x. If I take positive 4 out from 16, I left with positive 4. All right, so now as you can see, I have x plus 4 and x plus 4 common, so I can take it out. So I have x plus 4, and then what I am left with? Negative x square plus 4. So negative x square plus 4. So this is what? Equal to 0. All right, so now as you can see, I have two mathematical expression in product form. So I can write actually x plus 4 equals 0, and I can write down negative x square plus 4 equals 0. So I can say x equals negative 4. So this is one of my real zeros, and I can write down negative x square equals negative 4. I can write down x square equals 4. I can write down x equals plus minus square root of 4, which is plus minus 2. So finally what I found? X equals negative 2 and x equals 2. Okay, so so these are my three x-intercept or three real zeros. So let me plot these three real zeros in this graph paper. So one is negative 4, one is negative 2, another is positive 2. So I have one real zero, negative 4, another real zero, so another real zero at positive and negative 2, and another real zero at positive 2. Okay, so these are my three real zeros. Now I already got three real zeros. Now I'm going to look at a multiplicity. I just want to remind you guys from the previous lecture, if multiplicity is even, then the function is going to touch. If multiplicity is odd, the function is going to cross. Okay, so I hope you remember that. So now let's see for my this particular function, I got what? How many times I got x equal to negative 4? I got one time. So my multiplicity is 1 for x equal to -4. Okay, and what about multiplicity? How many times I got x equal to -2? Only one time, so my multiplicity is actually 1. And similarly, multiplicity is also 1 for x equal to 2. So these are what? All odd. So these are all odd multiplicity. So these are all odd multiplicity, and that means what? These are going to cross the x-axis. Okay, so my function is going to cross the x-axis at all these points. Okay, so it is going to cross the x-axis. So if I now say, so my function is going to what? Cross the x-axis at -4. So it is going to cross the x-axis at -4. So I am going to try to connect with the previous one. It is going to cross the x-axis with x equal to 2, and it is going to cross the x-axis at x equal to -2. Okay, so this is the 3 conclusion I can write. Okay, so my function is crossing at all the 3 points. Okay, so this is end of step number 2. So now let's do step number 3. So step number 3 is find the y-intercept. So find y-intercept. Now if you remember, how do we find y-intercept? We plug in, we put x equal to 0. Okay, that's how we find y-intercept. So let us see for step number 3. So let me do the step number 3 here. So my function is what? Y equals function of x. I'm rewriting just for clarity. So -x cube -4x square positive 4x plus 16. Okay, so if I plug in x equal to 0, so what is my y? So y is function of 0, which is equals what? 0 minus 0 plus 0 plus 16. So I got y equals function of 0 equal to 16. So what is my y-intercept? My y-intercept is at x equal to 0, y equal to 16. So let's plot this. So my y-intercept is somewhere here. Okay, so it is at 16. All right, so that's what I get. All right, now the last step is step number 4. All right, so before step number 4 is use test point method. So use test point method. All right, so I am going to explain the step number 4. So before I try to explain the step number 4, I want to basically try to approximately draw the graph. Okay, now again remember, these are all approximation, and I'm not going to claim that that is correct or incorrect. So just hear me out. Okay, now let's say my graph here is simply like that. Okay, and I have to connect my graph here. Okay, now what are the ways of connecting? Okay, if I try to connect the graph, so see this way. If I try to connect the graph this way, is it going to be a possibility? Think about it. I am having how many now zeros? 1 2 3 4 5. Now I cannot have what? More than 3 real zeros. That means what? It cannot cross here. Okay, so that means it cannot cross the x-axis anymore. So it is not a possibility. All right, now let us see the other possibility. Is it possible to do this way, connect this way? Now see, of course I still have 1 2 3 x-intercept, so I have 3 maximum zeros. Now I can have what? Only maximum 2 turning point. Now let's see how many turning points I already get. 1, 2, 3. Only here I got 3 turning point, but I might get more. So this is also not possibility. Okay, so this is not possible. So it seems that the only way to connect this is like that. Okay, of course we are going to confirm later. Okay, just leave it as a dotted line. So as again we are not claiming that this is the correct drawing. We are just leave it like that. Okay, so now let us try to see from how I can travel from here to here. Okay, first of all, when I am traveling, remember I need to go through what? That y-intercept. And how many y-intercept I get? I get only y-intercept. All right, so my graph cannot cross more than 1 point in y-intercept. And also if I keep in mind that I have 3 maximum real zeros and maximum 2 turning point, it seems that this is the only way to connect these two. Okay, so in this case, in this approximate drawing with the dotted line, I have 1 turning point here and another turning point here. So I am not violating my maximum number of turning point, which is 2. Okay, so let's leave it like that. Now let's see, we are going to use what? Use the test point method. So let me take another color. So for test point method, first of all, what? My number line is divided by what? This x-intercept into how many zone? 4 zones. So what are the zone? So my first zone is what? Negative infinite to negative 4. This is my first zone. What is my second zone? Negative 4 to negative 2. So this is what? Negative 4 to negative 2. This is my zone number 2. And then what is the third zone? Negative 2 to positive 2. So negative 2 to positive 2. And then the final zone is 2 to infinite. Okay, now so let me simply write down this zone name. All right, so what I am going to do, I am going to simply write down this zone name. So I am in step number 4. All right, so what are my zone name? So my zone names are negative infinite to negative 4, negative 4 to negative 2, and then negative 2 to positive 2, and finally positive 2 to infinite. Okay, and then we are going to choose what? Some test point. Okay, test point from each zone. Okay, so what I am going to do, I am going to pick some test point from each zone. So let me use another color so that we are okay with that. So let's say I am choosing a test point from the first zone equal to negative 5. I am going to choose a test point for the second zone as negative 3, and from the third zone I am going to put take a test point at x equal to 0, and from the fourth zone I am going to choose a point at x equal to 3. So these are my 4 test point. What I choose from the first zone, I choose a test point at x equal to negative 5, and from the second zone I choose a test point at x equal to negative 3, and from the third zone I am going to choose a test point at x equal to 0, and from the fourth zone I am going to choose a test point at x equal to 3. Now we need to find the sign of function of x. So the last is what? Sign of function of x. All right, so what I need to find? I need to find the sign of function of negative 5 I need to find the sine of function of -3. I need to find the sine of function of 0. I need to find the sine of 3. All right, so let us first of all let me write down what is my function of x, guys. If you remember, my function of x is negative x cube negative 4x square plus positive 4x plus 16. So what is going to be my function of -5? Function of -5 will be negative, and then -5 cube minus 4 -5 square plus 4 multiplied by -5 plus 16. So if you punch the number, so let me punch the number, which is 125 plus negative 100. So 125 minus negative 100 negative 20 plus 16. So it is I found it to be positive 21. Okay, I don't care about actually the number 21 itself. For me, most important is what? It is a positive sign. So what I found, that for a test point x equal to -5, the sign of my function of x is what? Positive. So let me put that sign here. So for x equal to -5, my sign is positive. So my function is positive on my first zone. So my function is positive on my first zone. What does it mean? That my function need to be always above x-axis, and which is already there. Okay, so that means at least this portion of my graph is correct. Okay, so now let us look at the other one, which is what? Let me write down function -3 cube -4 -3 square plus 4 multiplied by -3 plus 16. So if you punch all the number, this time I'm not going to write down the number, I'm going to write down the sign. So the sign will be negative for this case. So sign will be negative for a test point x equal to -3, and if you have chosen other, it will be also negative. So my function is negative in this zone, so that means my graph is below x-axis, which is already there. Okay, and then let's choose. So guys, just to remind you one thing, what is function of 0? Function of 0 is 16. So this time we are going to use this so function of 0 is what? 16, which is what? Positive. All right, so if it is positive, that means what? My function in this zone is positive. So that means it is above x-axis in this zone 3. All right, which is already there. And now finally let's find out function of 3. Function of 3 is negative -3 cube -4 multiplied by -3. Sorry, it's not -3, guys. Function of 3, so that means it is positive 3. Okay, so it is positive 3 square plus 4 multiplied by positive 3 plus 16. And if you punch all the numbers, you are going to actually find that it is negative. Okay, so if it is negative, so what does that mean? That my function value or sign at x equal to 3 is negative. So also it is going to be negative for all other values, that my function is going to be what? Below x-axis, which is already there. So if I now finally connect all the my graph in a solid line, so my graph is going to be like that. Okay, and also here it is going to be like that. Okay, so this is basically the final plot of my graph for this particular function. So that is how you basically graph any polynomial function. All right, So you follow these 4 steps and do this one by one. So I hope all of you understand it, and then so that will be actually the end of this section. So see you in next